So today we're going to do like a combination of what we did with the normal curve when you guys were drawing the entire curves out by hand and what we did with finding the z-scores, okay? You can actually, there's a way to do it in the calculator to figure out that percentage so you don't have to draw out the entire curves. The reason why I had you do that is so that you understand kind of what the calculator is actually doing for you, okay? So let's start off by saying this too. When you're finding that number, when you're adding all the percentages, you are calculating the probability or the percentage or the area under the curve. They all mean the same thing, so it can be asked different ways. Okay, so in the calculator, once you figure out, first you have to figure out the z-scores, but this is what you're going to press. You're going to press second vars, which is next to the clear button, and then you're going to press the second one in. It says normal CDF, and then it'll look something like this on the right that I have here. You'll see lower, upper, and then mu, which is the mean, and then the little, the other Greek symbol, which is standard deviation, and then it'll say paste, okay? So you plug in, so you're figuring out the area under two specific points. So you would have to figure out the z-score for the lower and the z-score for the upper. If there is no boundary, for example, if it says if a score is greater than something and it can go all the way up, then you're going to plug in 10 or negative 10. Negative 10 for lower, positive 10 for upper. Your mean is always going to be 0, and the standard deviation is always going to be 1. Okay, it makes more sense when we do an example, though, so let's look down here. Number 1, Chris takes a pretest to be considered as a contestant on a TV trivia game show. The people taking the pretest with him had a mean score of 108, a standard deviation of 8, and Chris scored a 120. Assume these scores form a normal distribution, meaning we can actually do all this stuff. So letter A, what is the probability of getting a score between 102 and 124 rounded to the nearest thousand? So last week you drew this whole curve. You found where 102 was. You found where 124 was, right? If 108 is in the mean, it's somewhere closer to 102, but it doesn't matter. You found where 102 was, you found where 124 was, and then you added all of those percentages in the middle, right? The calculator is going to do that for you. What you have to do, though, is figure out what the z-scores are for 102 and 124. So that's what we did last time. So we're going to do the 102 z-score. You would do 102. The value minus the mean is 108. Divided by the standard deviation is 8. That gives you a z-score of negative 0.75. Okay, so that's your lower boundary, negative 0.75. That's going to be the z-score. Then for the 124, you're going to do the same thing, just going to be a different number. 124 z-score. You would do 124 minus 108 divided by 8. That'll give you 2. So what you're going to do in the calculator is you're going to say, if I am negative 0.75 standard deviations away and 2 standard deviations away, what percentage of people, or really what's the probability of people that scored in between those 2 standard deviations? So you're going to go into your calculator. You're going to press second vars, number 2. Your lower boundary is the one that's on the left. So your lower boundary is going to be negative 0.75. Press enter. Your upper boundary is the right side. So that's 2. Press enter. The mean is always 0. So you type in 0, enter. The standard deviation is always 1. Type in 1, press enter. And then paste. Again, your work for this is going to be what it says on your calculator screen. So you have to write this down. This is part of your work. Normal CDF what it says on your screen right now. Normal CDF, negative 0.75, comma 2, comma 0, comma 1, meaning lower, upper, mean, standard deviation. And then you press enter. We are rounding to the nearest thousandth. You get 0.751. That's your answer. That's the probability of getting a score between those two grades. Letter B. What's the probability of scoring less than Chris? So again, I'm going to draw the curve just because I think it makes a little bit more sense. This is my curve. Chris scored a 120, which is above the mean. So it's a little bit to the right. And we want to know the probability of scoring less than Chris. So that goes back, all the way back. Okay? So I have to figure out where Chris is. What is Chris's z-score? So he got a 120. So the 120 z-score, you would do 120 minus the mean divided by the standard deviation, and his z-score is 1.5. So he's 1.5 standard deviations away from the mean. Now the problem with this is that this is on the right side of that shade, right? You don't have anything on the left. So if you're missing, so that means that you're missing the lower boundary. This is going to be negative 10. The reason why you choose negative 10 is because you know how when we did those curves, we went out to 3, and then after 3 standard deviations away, it was like less than 0.1%, and it just keeps getting smaller and smaller. By choosing negative 10 and 10, you're so far away from the mean that the percentages are so minuscule it doesn't even matter. So I just always say negative 10 and 10, and you guys usually stick with that pretty good. If you want to go out even further, you can. I don't recommend you go less than that. So at least negative 10 and 10. So you're going to go into your calculator again. Same idea, but now your lower boundary is negative 10, and your upper boundary is 1.5. So you're going to press second, vars, number 2. Your lower boundary, negative 10, press enter. Upper boundary, 1.5, press enter. The mean is 0. The standard deviation is 1. Paste. That's what you're going to write down. You're going to write down normal CDF. This is part of your work. Then you're going to write down negative 10, 1.5, 0, 1. Press enter. We're rounding to the nearest hundredth. The probability is 0.93. Okay. Letter C is a little bit different. The reason why is because this says what percentage of contestants. So the only thing that's different is that once we get our answer, once we get the number in the calculator, we have to turn that into a percentage. And you can do that. You can multiply the number by 100, or you can just move the decimal over twice. You're doing the same things when you do that. So we're looking for the percentage of contestants scoring higher than Chris. So I'm going to draw my curve. We know Chris is here, right? He's somewhere above the mean, and we want to go higher than Chris, right? So you can start to figure out, you have to figure out what his z-score is. We already did that, right? The 120 z-score, this is the same problem. So if his z-score was 1.5 before, it's 1.5 again. So this is at 1.5 standard deviations above. But now, that's your lower boundary. We want to be, lowest would be Chris's score, and then highest being going all the way up. So there is no upper boundary. If there is no upper boundary, you're going to use positive 10. Okay, so same deal. Second, vars, number 2. Your lower boundary is 1.5. Upper boundary is 10. Mean is 0. Standard deviation is 1. You press enter. You write that down for your work. Normal CDF. You have 1.5 is the lower, 10 is the upper, mean, standard deviation. You press enter. That gives you 0.0666807. I'm just going to write a few decimals out. We're looking for the nearest tenth of a percentage. So I move this over once, twice. So it's 6.68, which rounds to be 6.7%. Okay? If you look, these two numbers add together to be 1. Okay? I know the first one's more rounded, but they should add together to be 1 because you're going below Chris and above Chris. That includes everybody, which is 100%. And the last question. I just wanted to clean up the percentile thing. When I ask you for a percentile, I am asking for the percentage of people that scored at or below. At or below. So we're looking for the percentile rank for Chris's score. Chris's score is here. So at his or below. We know Chris is at 1.5 standard deviations away. There's no lower boundary, so it's -10. We did this with letter B. It's essentially the same question, just asking you for the percentage. So when you go through and do this whole thing, you're going to write this down here, because that's the work for it, and you get 0.93, but we're looking for the percentile rank, so the percentage. So his answer is the 93rd percentile. So he did very well. The 93rd percentile scored up there. Okay? Tomorrow, be on the lookout for your practice questions. Let me know if you have any questions or concerns about anything. Have a good day.